Hi, welcome back to Maths Masters. This is the addition session 4, and in this session we're going to be looking at adding by making 10. So this will involve partitioning, breaking up numbers into parts, into their number bonds, and regrouping them with other numbers to make it easier to add them on. So it's called adding by making 10. So we're going to partition them and regroup them. So this is really useful for mental calculations later, for mental addition later. Knowing your number bonds to 10 off by heart, this is why it's really useful. In the brain, we have a long-term memory and we have something called the working memory. The working memory processes information that comes in as we're going along. So if we're trying to solve a problem in maths, it's the working memory that's going to be involved with that, but also the long-term memory. Now, the working memory only has the capacity to hold 3 or 4 chunks of information at one time, and then beyond that it goes into cognitive overload. It's cognitive is thinking, and there's too much thinking, it goes into overload and it's not able to cope with all the different things that it's trying to do. So it becomes very difficult to solve problems when we're experiencing cognitive overload. So we need to free up our working memory to do problem solving and try and have as much things in long-term memory as possible. Now, to strengthen our long-term memory, if we know our number bonds to 10 and we practice breaking up numbers within 10, breaking up numbers so we know number bonds to 7, 6, 8, 2, 5, the more we practice that, the quicker that recall will be from long-term memory. So it strengthens those neural pathways. So when we need the information from long-term memory, it's like the wires are hardwired and they're a really good connection. So the brain can quickly go and get that information and bring it back really quickly. And the more we practice that, the better we will be at recalling that information and building those bridges, building those wires to long-term memory. A struggle sometimes helps with that. So when you put emotion or any kind of extra thought or attention to something, that can help embed information into long-term memory. So the more you go back and try and retrieve it and struggle to get that, the better those connections will be. So this is why number bonds are really important. So we're going to have a go today at making 10 to add numbers. So if we start with the number 8 add 7, then what we can do is, if we start with the number 8, so a tens frame is very useful to show this. We've got 8 counters there and we want to add 7. So what we can do, if I get another tens frame, rather than just putting 7 counters on this tens frame, what we'll do is partition that 7 up into 2 parts. So put half of it there, well not half, but less than half of it there, and some of the number here. So I've got 7, then wanting to add on to the 8. So I'll count out 7 counters. And what I'm going to do is I'm going to partition, break up those 7 counters so that I can do the addition. I'm going to add by making 10. So I've got 8 there. I know my number bonds. I know 8 and 2 makes 10. So I know to put 2 there. I also can put 5 there. Then it's easier for me to make the calculation. So I know I've got 10 and 5 together. 10 and 5 together is equal to 15. So what I've done there, the 8 and the 7, if I show here, 8 add 7, What I did with the 7, rather than putting 8 in my head or counting 8 objects and counting on 7, I've partitioned 7. Now I know the numbers that go together to make 7, and I know the numbers that go together to make 10. I know that 8 and 2 make 10. I can see it visually there. So start off with using the tens frame, using number lines, using beads on string that will really help you to see it visually. So I've got 8 there, I know I need 10, and I know that I can split 7, partition it into 2 and 5. So what I do is, I recombine that number, I partition and recombine. So I have 8, add 2, add 5 is equal to 15. Because I've got my 8, then I've added 2 on to make 10, and then just added the 5 on to make 15. So that is partitioning and regrouping. So we can try that with a different one. We can have 5 to start off with. So we've got 5 and we want to add 5, add 7. Now, the last session, session 3, we looked at the commutative property of addition, the fact that we can add the parts in any order. So what I'm going to do now with this, because I know it's easier to start with 7, it's easier to add from the bigger number, so I'm going to turn this calculation around. It doesn't matter, you'll still get the same answer, but I'm just doing that to make it easier and more efficient and make sure I'm more reliable. So I'm going to turn it around to 7, add 5. So I've got 5 counters there. I'm going to make it to 7. And so I'm going to add 5. Now I'm not going to just count 5 on, I'm going to partition 5, and I'm going to partition it into 3 and 2. And you can see that by getting your 5 counters. If I have them down here first so we can see. So it helps if you get your 5 counters there, and then you can think, right, okay, how am I going to partition these? How am I going to split them? How do I know what goes there? So if you've got your tens frame, you've got 8, we haven't got 8, have we? 7, sorry, I've got 7 there, and then I've got my 5 counters, so I can think, right, how am I going to partition them? Well, 3 there, so I'm going to partition 5 into 3 and 2. So I've partitioned them, I've regrouped this now, so I've got 8, so I've got 7 and 3 and 2. So now my calculation looks like this: 7 add 5. I partitioned the 5 into 3 and 2, so that is equal to 7 add 3 add 2. So 7 add 3 we know is 10 because we know our number bonds to 10. Add 2 more is 12. Okay. So I'd like you to have a go now. Use the tens frame. Use counters if you like. Have a go at adding 4 and 7. You might want to turn the parts around to make it easier to do. So if you want to start with 4, or if you want to start with 7, you can have 7 counters and 4 counters. So think about how you're going to partition. I'm going to change that around. So we've got 7 and 4. So how are you going to partition the 4 to recombine it to make 10 and then add the number together? So pause me, have a go at that. Okay, so Now, hopefully you've had a go at this. You've got 7 there. So what happens is, when we put, you can use the second tens frame. 3 of them would go there and 1 there. So we partition this into 3 and 1. So our number sentence is now 7, add 3, add 1, which 7 and 3 go together make 10, and 1 gives us 11. Have a go at this next one now. Add 5. So, you've got 6 there, and you need to add on 5 more. So you're going to partition the 5. Think about how you're going to partition it and how you're going to recombine it to add it together. So pause me and off you go. Okay, so 6 and 5. Well, if we place the counters there, we will see that we can partition 5 into 4 and 1, because 6 and 4 is going to make 10. So we have 6 add 4 makes 10, and add 1 is equal to 11. And we can see we've got 10 there and 1 there, which is 11. The other way of doing this is to try using a number line. Now I've got a tape measure instead of a number line. You can draw out a number line, or if you've got a tape measure, that's quite handy to use. So if I was doing the one that we've just done, 6 add 5, what I will do first is beginning at 0, and count on to 6, or because we know there is 6 there and we're finding more, we start at 6 and we add in on 5. Rather than going in steps of 5, I'm going to partition it to get us up to 10, to make the 10 altogether. So 6 add 4 makes 10, add 1, and then we get to 11. Okay. You might want to draw your own number line. So if we have 8, add 9. We can start at 8. And we can add on split 9. Well, I know that 8 and 2 makes 10. So we can split 9, partition it into 2 and 7. So 8 add 2 is 10. And then I can add 7 more on. So 10 add 7 is 17. So have a go using a number line. Try these ones. So have a go at 9, add 4, so partition 4, and then regroup, and then have a go at 6, add 8. Pause me, off you go. Okay, so hopefully you've had a go at doing 9 add 4, so you could have used the number line. So if we make a number line, we can start at 9, or we can start at 0 on your number line, it doesn't matter. So we have 9, add 4, let's get rid of that. We can partition 4 into 1 and 3, because 9 and 1 is going to make 10. So we add 1 on to make 10, and then we can add 3 more on to make 13. Okay, Now the next one, 6 add 8. I'm going to change the colour so it's clearer for you to see. I've got 6 add 8. So you might want to use the tens frames to do this one, to do the 6 add 8, or you might want to use a number line. So if we have our number line, ideally use a ruler. So starting at 6, and I can partition the 8 into 4 because I know 6 and 4 makes 10. So get to the next 10, counted 1, 2, 3, 4. And that leaves me, because I know that 4 and 4 makes 8, I've another 4 to count on, which takes me to 14. So 6 and 8 is equal to 6, add 4 equals 14. Some of you might have changed that around, the commutative law of addition, where you can change the parts around. So you might have had 8 add 6. So you would have start at 8 and get to the next 10, so adding 2. So break the 6, partition the 6 into 2 and 4. So add on 4 more and you will still get to 14. Okay. So in the activity section today, there is going to be some problems using the tens frames or the number line, but they're going to be problems where you need to make 10 to add. So you have to partition and regroup the numbers. So problem for today. Amir makes 10 to add. He wants to partition and regroup. Which method would you suggest? Have a think about those. So pause it for a moment and have a think about those ones. Okay, so Amir wants to use the method of making 10 to add. So he's partitioned the numbers. Which one would you suggest is the correct way? So here we've got 7 add 6. Partitioned, yes, 2 and 4 partitioned to make 6. But that doesn't help us. 7 and 2 doesn't help us to make 10. That just makes 9. So that's not going to help. Here, he's partitioned the 4 and the 3. So that isn't really going to help us here. It would if we turned it around, if we had 6 add 7 and we partitioned that, because then we could make a 10 there, but not on the way we've got it there. This one here, 7 and 3, that makes 10, and then we can add the 3 on to make 13, so that one's correct. Here, 7 and 1 makes 8, so it's not adding to make a 10, so that one doesn't work either for what we're doing. Right, in some of the problems that you've got today, you'll see some of them like this in the activities. 11 is equal to 7 add 3 add what? Okay, so this number sentence has got a missing number, and you can use a tens frame or you can use a number line to work out how this number sentence has been made, what has been partitioned and regrouped to make the number. So the original number was 11. So it's made up, it's been partitioned into 7 and 3 and another number. So how do we make 11? Well, 7 and 4 makes 11. So it's 7 and 3, which makes 10. and 1 more makes 11. So 7 add 3, add 1 makes 11. So it's 7 add 4. So what's happened is that's been partitioned in 3 and 1, because 7 and 3 make 10, add 1 makes it to 11. The next one, 13 is equal to 8 and something and something. Okay, so what numbers have made 13 with 8? So how has this person partitioned the other number to make 13? So what number did they have here? So we can make 8. We've got 8 and we need to get to 13. So I'll make it up to 10. So when we make it up to 10, that makes 2. 8 add 2 makes 10. And then we need 3 counters here to make 13. So we've got 8 add 2 makes 10. Add 3 makes 13. So what that will have been is 8 add 5 equals 13. And the 5 has been partitioned into 2 and 3 because the 8 and 2 make 10. One final problem with this today is imagining that there is a double-decker bus. So this is the double-decker bus. And the bus has to be filled from the top. There are only 10 people allowed to sit on the top of the bus. Let's get rid of that because there's not 10 at the top there. Let's draw our bus. Okay, double-decker bus. 10 people are allowed to sit at the top, 10 people are allowed to sit at the bottom. And the bus driver says that you've got to fill up from the top first. So, there are 6 people on the bus already when it comes to the bus stop. 6 people there. There at the bus stop, there are 8 people waiting to get on the bus. And the bus driver said they must fill the top up first. So, how will you partition this number to make sure the top is filled first? Have a think about that. Okay, so we've got 6 there. So if we have 6 on our tens frame, we can add on 4 more to make it up to 10. So we can partition this into 4 and 4. So we've got 10 now at the top of the bus, and 4 of them will then have to be on the bottom level of the bus. So what that looks like is a number sentence. We had 6 and we wanted to add 8. So what we did is partitioned the 8 into 4 and 4, because 6 and 4 makes 10, and then we can add the 4 on. So 6 add 4 equals 10, is equal to 10, add 4 is equal to 14. Okay, so rewatch that if you need to practice. Have a go at the activity section. There's going to be different questions that get more challenging. Choose how you feel in terms of your confidence. Use the tens frame, use beads, use counters, use the number line. Okay, I'll see you back here for addition 5.